Hi guys, welcome back to Ferris Tutorials. In today's session, we're looking at raisin agents used in food preparation. Food, nutrition, and health. Section 4, food science and technology. And in today's session, we're looking at content 12, raisin agents in food preparation. Now, let's take a look at our focus points. So we'll be looking at the functions of raisin agents in flour mixtures, classification of raisin agents, and the description of how each raisin agent works. But first, let us define what is a raisin agent. A raisin agent may be defined as something that causes baked goods to rise and become light in texture. Raisin agents are added to baked products during the preparation stage. They create gas, air, or steam which expands when heated and causes the food to rise. Examples of mixes that require aeration, meaning they require air being added to the product. These items are cakes, bread, and butters, right? And as the name suggests, raisin agent is something that causes baked goods to rise, right? As the name coming from raisin. All right, now let us look at a little bit further. And we're looking at the classification of raisin agents. There are different types of raisin agents that can be used, right? And these classifications are mechanical, also known as physical, chemical, and also biological, right? Now, different foods may use one or more of these to achieve a desirable product, all right? And first up, let us look at mechanical raisin agents. Now, air is a commonly used and effective raisin agent. It can be added to a mixture in a variety of ways. Now, did you know that air is a raisin agent? Yes, it is. It is one that is not commercial, meaning that we can't go to the supermarket and purchase it, but we can incorporate air or aerate the product in the following ways. So we're looking at sifting flour, creaming fat, whisking to trap air, beating ingredients together, and also rolling and folding pastries. Now, let us look at sieving flour. So sieving flour or lifting flour when rubbing in fat, example, pastry scones or some cakes, or we may even say rock cakes or rock bun. So when we sift the flour to remove any foreign matter or impurities from the flour, we're also adding air to the flour, right? And that acts as a raising agent. Also, when we're lifting flour, when we're rubbing the fat into the flour with our fingertips, and we grab the flour, pull it up, and we rub until it looks like what? We may say coarse cornmeal or fine breadcrumbs, right? Now that action or that process actually incorporates air into the product. Now the next is creaming fat and sugar. Now creaming fat and sugar helps to trap air into the product, right? Example, cream caked mixtures. So we may be speaking of, say, orange cake, it may be pineapple cake, all right? There is also whisking to trap air. Example, eggs whisk to create a foam for sponge cakes, meringues, or souffles, right? There is also beating ingredients together. It helps to trap air, example, beating eggs in a creamed mixture. And finally, we're looking at rolling and folding pastry. Now, what this creates is laminations where the air traps, example, in when we're making flaky pastry or rough puff pastry. Now that is why when you may be having, like, say, a Jamaican patty, you may find the flakes that are falling off, right? Those flakes were created during rolling and folding, and that also helps the product to have a little rise. Good. Now, mechanical raising agents are also known as physical raising agents, because we actually do the physical work to trap the air into the product or to aerate the product. And just to review, these are rubbing in, which is rubbing fat into the flour. So when we lift the flour and we rub between our fingertips, beating, as well creaming, folding in, whisking, and also sieving. And that is why it is very important also for us to fold in carefully when we're folding the dry ingredients with the liquid ingredients, so we not only enable the mixture to be mixed evenly, but also we're trapping air as well. Good. All right, now let us look at how steam acts as a raising agent. Now, steam is a common physical raising agent. It is produced from the liquids, example, water, milk, or eggs. And these are the liquids that we may use in a batter, right? Liquid is also derived from water contained in a solid component, example, butter, right? Now, examples of recipes which use steam as a raising agent are batters, such as the Yorkshire pudding and choux pastry, right? Now, they require a high oven temperature to produce the steam to raise the mixture. This produces a light open texture with large pockets of air after the steam has escaped. Steam also works with air and carbon dioxide in cakes and bread, as well as with air in pastry to help increase their volume, right? And earlier we were speaking about we may use one classification of raising agent. It may be chemical raising agent, or most time it's a mixture. So you may find that the techniques that you use when you're making a cake also helps to incorporate air into the product. And as it relates to steam, when the liquid in the mixture when they are heated, they create steam, and these may be water, it may be milk, it may be eggs, or any form of fruit juice, or any other liquid. It may be the liquid content from the butter that evaporates and creates steam that aids in raising the product rising, right? And examples of those products, as we said before, are Yorkshire pudding or choux pastry. Good. Now let us look at chemical raising agents. Chemical raising agents are those that require a chemical reaction in order to function. Common examples of chemical raising agents include baking soda, also known as bicarbonate of soda, and baking powder. And baking powder is made from a combination of baking soda and also cream of tartar, right? So baking soda or bicarbonate of soda plus cream tartar gives us baking powder. Baking soda is an alkali that reacts with an acid in the presence of water to produce carbon dioxide, which causes rising. Now you may get an exam question that asks you, how is it that baking soda allow, for example, chocolate cookies to rise, or how does it aid in the rising of, say, a chocolate cake or a red velvet cake? Now these are the things that you are required to put, right? So baking soda is an alkaline and it reacts with an acid in the presence of water to produce carbon dioxide. Now when this reaction takes place, this is when the product starts to rise, right? An example too, you may notice whenever you're making a chocolate cake or a red velvet cake and it asks for baking soda, what else is also on that recipe? An acid, right? And an example of that acid may be vinegar. Awesome. Now, baking powder is baking soda with an acid, and that acid is cream of tartar, right? It is already present, so only water needed to be added for it to be activated to create that carbon dioxide, right? So any ingredient, any recipe that you see baking soda, you must also see an acid for it to react so it can create carbon dioxide, which aid in that rising. All right. Now, the next classification that we're looking at is biological raising agents. Yeast is a biological raising agent. There are different types of yeast available that can be used to make breads and bread products. Now, examples of these yeasts that are available are fresh yeast, dried yeast, and instant yeast, or we may say easy blend, right? And you can see some examples here to the right of your screen of the different types of yeast that are available to use in bread products, right? Now, given the right condition, which is warmth, we have carbohydrate, but we may also say food, and moisture. Now, in most cases, the carbohydrate here that is used to activate the yeast, if it's instant dried yeast, sugar can be added so that the yeast can feed on that food, right? So in order for yeast to activate, it must have warmth, it must have some form of food, in we may say carbohydrate and moisture. And you know that carbohydrate can be in different forms, right? Now, yeast converts sugar to alcohol and carbon dioxide. This is called fermentation. The carbon dioxide in the bread dough will expand when placed in a hot oven. Steam is also produced to help rise the dough. So you see, we're also using a combination of raising agents as it relates to using yeast, right? So let us now review at the key points, right? Now, yeast is a biological raising agent, right? There are different types of yeast. There is fresh, dried yeast, and instant yeast, right? Now, given the right condition, which is warmth, carbohydrates, and moisture, yeast converts sugar to alcohol and carbon dioxide. And based on our previous classification of raising agents, you know that carbon dioxide is vital as it relates to these raising agents actually rising or aerating the product, right? Now, that process is called fermentation, right? Now, the carbohydrate in the bread dough will expand when placed in a hot oven. So guys, when the yeast feed upon the warmth and the carbohydrates and the moisture, what they do is to convert the sugars in the carbohydrates to alcohol and carbon dioxide. And this is the fermentation process, and carbon dioxide will raise the product when it is placed in the oven. So if a question asks you how yeast raise bread or hard-dough bread or cinnamon rolls, anything that uses yeast, it is the same principle for any product, yeast bread, that you are given a question for. Good? Now, the conditions that affect yeast fermentation are temperature, moisture, and food. So if the yeast bread did not rise, it is a possibility that one or more of these things were affected, right? Now, the first one that we're looking at is temperature. The best temperature range for yeast is between 25 degrees to 35 degrees Celsius, right? If the temperature is too high, the yeast cells are destroyed. If it is too low, the action is slowed. So we have to ensure that we get that nice tepid temperature, that lukewarm temperature, so that warmth, right? So not too hot, not too cold, because if the temperature is cold, then guess what? The fermentation process will take a little longer, and also it may affect the amount of carbon dioxide that is produced when the item is in the oven, and thus it will affect the volume of the end product, right? There's also moisture. This is provided by the liquid in the dough. This should be at the correct temperature as well. Because what will happen if it's too cold? Awesome. The yeast action will be slowed, and if it's too hot, the yeast cells are destroyed. Therefore, the product will not rise. Now, the third condition that may affect yeast fermentation is food. Now, this is supplied by the starch in the flour. And sometimes, depending on the type of yeast that is used, we may need to add a little sugar there to jumpstart the process, the fermentation process as well, right? Now, other ingredients can also affect the action of yeast, and one of these ingredients is salt. Now, excess salt will slow the action of yeast by drawing the water out of the cells and destroying them, right? So think about it. Just as with salted cod, when the salt is added, and guess what? What's the purpose of the salt? It's to pull the moisture from the fish. Likewise with yeast, right? As a biological raising agent, the moisture will be pulled, which is needed for the yeast to perform, right? So salt affects the rate at which the yeast would perform. So we have to be very careful of not using excess salt. Now, the next ingredient is fat. A high fat content will slow the action of yeast. So rich dough recipes often have a higher proportion of yeast to flour. Now, rich doughs are those yeast breads that have what? Adequate amount of fat and sugar. So we may say they are sweet yeast doughs, right? Now, we have to be very careful, because too much fat will what? Will slow the action of the yeast, and that is why we have to ensure that the proportion of yeast to flour is accurate, so the yeast will not be slowed. All right, the next ingredient that may affect the action of yeast is sugar. Normally, adding sugar will speed up the yeast growth, but large excess of sugar can bind water, actually inhibit the yeast growth, right? So we have to be very careful. So just as with, think about it, when you're making jams and jellies and we're using sugar as a preservative, right? What it does, it helps to pull out the excess moisture from the solution so that it can be what? Thickened, right? Just do with same as with tambourine balls. What the sugar there does is to help to bind the water content so that it can be preserved for a longer time. Good. So we have to be very careful when we're using these ingredients. Ensure that we follow the correct recipe and the right proportion as well. Now let us look at combining raising agents. The different types of raising agents are sometimes used together to aerate a mixture. A creamed cake mixture is a good example. Now let us look at what a cream cake mixture uses. So it uses mechanical raising agents. How? Air is added by sieving the flour, creaming the fat and sugar, and also beating the egg. As it relates to the physical raising agent, steam is formed from the liquid during cooking. And finally, with the chemical raising agent, carbon dioxide is released from the baking powder or self-rising flour when the liquid is added and during cooking. All right. Now, carbon dioxide is produced by the action of heat and moisture on baking powder. The carbon dioxide enlarges the air cells and aerates the mixture. The gases produced expand on heating and raises the mixture as well, right? Now, just to summarize how raising agents work. Now, when we use the appropriate raising agent for the mixture and it is evenly distributed, when it is heated, one of the following will take place. Well, one or more of the following. So 1, air will expand. 2, steam is produced from liquids. And remember, the liquids may be milk, it may be water, it may be eggs, it may be some moisture from the butter, right? And this enlarges the air cells, the steam escapes and is replaced by air. 3, carbon dioxide is produced when moisture and heat act on baking powder, or similar. The carbon dioxide enlarges the air cells and aerates the mixture. The gases expand when they are heated. And 4, carbon dioxide produced by yeast cells expands due to the heat of the oven. So as you can see with these raising agents, right? The chemical raising agents, what? The main factor there is when the carbon dioxide is created to increase the volume or to aerate the product. Now let us look at our questions. Number 1, state the function of raising agents in flour mixtures. 2 marks. What are the different classification of raising agents? That should have worth about 3 marks. And how does baking powder work in baking muffins? So you have to think of the different things that we looked at how baking powder reacts when moisture is added and also when heat is added. What happened to the mixture? Now, based on the discussion that we had, I am sure you're able to answer these questions. You are awesome. You've made it to the end of the session. Did you find this video useful? Give it a like. Also, ensure that you have pressed that subscribe button and turn on your post notification bells so you can be notified when there's another upload. One more thing. Don't forget to share with persons who you know will find this information useful. Thank you for making it Ferris Tutorials.